about the topic solid state. Okay, in this chapter we are going to study what are the different types of the solids, then unit cells, crystal lattices, and then different imperfections in the solids, and again we are going to study different packing efficiency and close packing. Okay, yes, at first we'll see what is the solid state. We know that states of matter usually consist of three states, that is solids, liquids and gases, and these three states are usually interconvertible each other by heating followed by cooling. Then how to get the solid state in the stable state? In the stable state, how to get the solid state? For the stable solid state, we have to maintain the condition, that is thermal energy and intermolecular attractive force. Because we know that as the thermal energy increases, what happens? The intermolecular attractive force in between the particle that will be slowly reduces and it will changes its state from solid to liquid, liquid to gas. Because we know that in case of the solid, particles are closely arranged, right? So as the temperature increases, what happens? There is the attraction that will be slowly reduces. That is, intermolecular attractive forces will be slowly reduces. Therefore, for the stable solid state, what condition we have to maintain? That is thermal energy and the strong intermolecular attractive force. Okay, now we'll discuss what are the properties of the solids. What are the properties of the solids? We know that solids are having definite shape, definite volume, and in between the particle there is a strong intermolecular attractive forces present, and the intermolecular distance, it is very short. Because of the strong attractive force and short intermolecular distance, these solids are usually rigid in the nature. Remember, these solids are usually rigid in the nature. And because of the absence of gap in between the particle, the particles in the solids are oscillate on their own position. Okay, it will oscillate on their own position. There is a restricted movement, restricted position, restricted movement for the particle. There is no gap. Since there is no gap in between the particle, it can't move around like liquid and gas. Particles can't move around in the space. There is a restricted movement for the particle that it oscillates on its own position. Therefore, the solids are highly incompressible in the nature. Okay, and once again we will discuss the properties. These solids are usually having the definite shape and are having the definite volume, and intermolecular forces are strong. Then intermolecular distances are short. Okay. And here the particles are oscillate on their own position. Particles are oscillate on their own position. Since the particles are oscillate on their own position, the solids are highly rigid in the nature, as well as these are incompressible in the nature. Okay, right. So solid state, for the stable solid state, we have to maintain the thermal energy and the strong intermolecular force of attraction. Then we will discuss the different type of the properties, that is a definite shape and the volume. Solids are having the strong intermolecular force of attraction. Solids are intermolecular distance, and because of the absence of gap in between the particles in the solids are usually oscillate on their own position, and because of the the short distance and strong force and oscillate in their own position, these solids are highly rigid in the nature and incompressible in the nature. Okay. Next, we'll discuss what are the different types of the solids. What are the different types of the solids? Right. Based on the force, based on the intermolecular attractive force, there are two types of the solids are present. Okay. There are two types of the solids are present. First one is crystalline solid, and the second one is amorphous solid. Crystalline and amorphous solid. Yes, as the name itself indicates, crystalline in a definite form, amorpha in the sense no form. Okay, crystalline solids means here the solids, inside the solids, the constituent particle, that is atom, ion or molecules of the solid, it has got the definite geometrical shape, definite arrangement, that in the sense the crystalline solids, see the particles, I'll write the particles in the circle. Okay, so these are the particles in case of the crystalline solid. But in case of the amorphous solid, I'll write the particle in this way. Okay, right. Crystalline solids, in case of the crystalline solid, first we'll discuss the different properties of the crystalline solids. Crystalline solids means here the constituent particles, that is atoms, ions or molecule, the constituent particles having the definite geometrical shape. Okay, here the constituent particles are having definite geometrical shape. Constituent particles are having definite geometrical shape. And second point, in case of the crystalline solid, the particles are orderly arranged, as well as that arrangement, we can see that arrangement throughout the solid, and the repetition of the particle again and again, that will be repeated again and again throughout the solid. Okay, we can observe the repetition of the particles in the solid, and here the constituent particles repetition can be observed again and again in the solid throughout the solid. Therefore, here the crystalline solids are usually having the long range. It is usually having long range order. Particles are usually having long range order. What is a long range order? As I said already, here the particles are repeated again and again throughout the solid many times. Okay, if I write this is A, this is a B, again A, B, that repetition can be observed throughout the solid many times. Okay, so therefore it is usually having the long range order. Third point, this crystalline solids, because of the definite geometrical shape, because of the long range order, it has got the sharp melting point. Sharp melting point. It is usually having sharp melting point. That means it usually melts at the particular temperature. At constant temperature, it starts melt. Okay? Right. Next, these crystalline solids are usually called as a true solids. Why it is usually called as a true solids? Because since it is having sharp melting point, having and definite geometrical shape and having the long range order, these are usually called as the true solids. One more important properties of the solid is crystalline solids are anisotropic in the nature. Anisotropic in the nature. Crystalline solids are usually anisotropic in the nature. Yes, all the properties are positive properties. You can say that since the crystalline solids are having definite geometrical shape, long range order, sharp melting point, true solid, even though these are anisotropic in the nature. What is anisotropy? Isotropy and anisotropy. What is the difference between the isotropy and anisotropy? See, isotropy means it's a property. That means same physical property in all the direction. Then it is called as isotropic in nature. Same physical properties in all the direction. Even though it is having this about a long range order, definite geometrical shape, it is anisotropic in the nature. That is different physical properties in all the direction, in different direction. Why the crystalline solids are having different physical properties in different direction? Anisotropic definition, note down the definition. Anisotropic, why the crystalline solids are anisotropic in the nature? You may have the questions. One more question, why the crystalline solids are anisotropic in the nature? Anisotropic means what? Different physical properties in different direction called as anisotropic property. Okay, so we'll see why the crystalline solids are usually anisotropic in the nature. Okay, I'll write the simple crystalline solid here. A, B, A, B. Again, B, A, B, A, B. So in this way, repetition, we can observe the repetition. Okay, since it is the long range order, crystalline solids are long range order, that repetition can be observed throughout the solid, that repetition of the particle can be observed. Okay, I'll write one direction. So in this direction, I'll write it as A. Okay, this is one direction. AB pattern repeated. And again, in this direction, I can observe different pattern, that is BA pattern. Again, if I write in this way, in this direction, that is C, we can observe the BD pattern repetition. Okay, and if I consider this direction, again, this AA pattern is repeated. Okay, here AB pattern, here BB pattern, and here AA pattern. Yes, here, since in the crystalline solid, even though the particles are orderly arranged at definite arrangement or definite geometrical shape here, we can observe the different physical properties in different direction. It is because of the different arrangement of the constituent particles. Okay, if I study the physical properties, what are the physical properties? One is a refractive index, then the thermal conductivity, thermal expansion and its melting point, etc. Different physical properties. So here in this direction, since AB pattern, I can observe one refractive index, the thermal expansion or thermal conductivity is different here, electrical property is different in this direction. Again, if I study the same physical property in this direction B, it is BABA pattern. Again, there is a changes in the physical property. Therefore, we can observe the different melting point, different thermal conductivity, different electrical property, and in this direction again AA pattern. Again there is a different physical property. Again here in the here also there is a different physical property. Okay, so therefore, since the different arrangement of the particle, since different pattern in the different direction, different arrangement of the constituent particles in the different direction, we can observe the different physical properties in the different direction. Okay, so therefore crystalline solids are anisotropic in the nature. I'll repeat again, why the crystalline solids are anisotropic in the nature? It is because in case of the crystalline solid, the different arrangement of the constituent particles in different direction. Okay, so because of the different physical properties in the different direction, these crystalline solids are anisotropic in the nature. So since the different refractive index, thermal expansion, electrical properties, etc. is different in different direction. Since it is different in different direction, it is anisotropic in the nature. Okay? So these are different important properties of the crystalline solid. Crystalline solids are having definite geometrical shape, and it has got the long range order, and it is having sharp melting point, and these are usually the true solids, and these are anisotropic in the nature. Now we'll discuss what are the different properties of the amorphous solids. As I said already, amorpha in the sense no form. Here we can observe that no form in the sense there is no definite arrangement of the constituent particle. Here I said A, B, A, definite arrangement of the constituent particles are there. In case of the amorphous solid, to a certain distance we can see the definite arrangement of the constituent particle. Then again irregularities can be observed. Then again you can observe the regularity, again irregularity. So therefore in the throughout the solid we can say that totally there is irregularities in the arrangement of the constituent particles. Okay, so amorphous solids. In case of the amorphous solid, we write the first reference. Here the particles doesn't have the definite geometrical shape. So there is no definite geometrical shape. No definite geometrical. There is no definite geometrical shape. And in case of the amorphous solid, it doesn't have the long range. Only to the short distance we can observe the repetition of the particle. Therefore, it has got the short range order. Short range order. Okay? And these amorphous solids are usually having the variable melting point. Variable in the sense it doesn't have the sharp melting point. It melts at variable temperature. Okay, it melts at variable temperature. So therefore, we can say that it doesn't have the sharp melting point or variable melting point. It melts over a wide range of temperature. So therefore, we can say that it doesn't have the sharp melting point or variable melting point. Variable melting point. Okay. Since it melts at different temperature, it is usually called as a pseudo-solid. Remember, important difference it is pseudo-solid. This is pseudo in the sense false. Pseudo-solid. Okay. You may have questions like why the amorphous solids are pseudo-solids. Why it is a pseudo-solid? Because it doesn't have a sharp melting point. Since it melts at variable temperature, it is usually called as a pseudo-solid. Okay, and yeah, its properties, amorphous solids properties are little bit same or little bit similar to that of the liquid. So therefore, this also be called as these amorphous solids are also be called as a supercooled liquid. Why it is called a supercooled liquid? Because it, as I said, at a variable temperature, it changes its state from solid to liquid, and therefore it is also be called as a supercooled liquid. It has a property similar to that of the liquid. Okay, so at higher temperature, its property similar to that of the liquid, or it has a tendency to flow like a liquid. Okay, so here amorphous solids have the tendency to flow like a liquid. Therefore, it is also be called as a supercooled liquid. Inside the bracket, I will write this is also be called as a supercooled liquid. Why it is usually called a supercooled liquid? Because it has a tendency to flow like liquid at variable temperature. Therefore, it is called as a pseudo-solid. Okay. And one more important property, that is amorphous solids are usually isotropic in the nature. Isotropic in the nature. Amorphous solids are usually isotropic in their nature. isotropic in the sense same physical properties in all the direction. Okay, since it possesses the irregularities throughout the solid, it is usually having the same physical property in all the direction. But in case of the crystalline solid, in different direction, different physical property. But if you study the physical properties in amorphous solids, refractive index, thermal conductivity, melting point, electrical property, etc., it is usually same throughout the solid. So therefore, same physical property in all the direction. Therefore, amorphous solids are usually isotropic in the nature. Okay, again we will discuss amorphous solids. It doesn't have the definite geometrical shape, and it is usually having the short range order, and it melts at the variable temperature, so therefore variable melting point will be there, and these are usually pseudo solids, not true solids, and also be called as a supercooled liquid, because like a liquid it has a tendency to flow, therefore it is a supercooled liquid, and it is highly isotropic in the nature because it is having the same physical properties in all the direction. Okay, we'll have the examples for crystalline and amorphous solid. We can give the example for crystalline solid, we can give the example sodium chloride, we can give the examples and other crystals like sodium benzoate or we can give some examples sodium chloride I said, cesium chloride, lithium chloride, ionic solids, we can give the example for the crystalline solids. Okay, some of the metals also be the example for the crystalline solids. Whereas amorphous solids usually plastics, polymers, okay. The polymers, under the polymer itself plastics comes, plastics, rubber, glass, etc. Example for the amorphous solids. Okay. Right. So under this particular topic, you will be having the questions like what are the properties of the solids? You will be having the questions, okay, under this particular concept. Okay, you will be having what are the properties of the solids, what are the different properties of the solid. You have to remember what are the different properties of the solid. Then what are the types of the solid. Okay, under the types of solid, at least for two difference, minimum two difference, you must remember at least two difference. Okay, then under the properties itself related to the isotropic and anisotropic property, you will be having the questions. Okay, why the crystalline solids are anisotropic. Isotropic in nature. Crystalline solids are anisotropic in nature. Justify. Okay, crystalline solids are anisotropic in nature. Justify. Similarly, amorphous solids are isotropic